Hello everyone, I welcome you all to D2R Design Academy. In this video, we will discuss about modeling in ETABS having mass irregularity as per Indian Standard 1893-2016 code. Like this, I will be bringing out latest videos on jobs as well as internship opportunities at various or reputed organizations. So don't forget to subscribe to my channel to receive such beautiful updates. So now moving forward, as per IS 1893, it states that the mass irregularity can be considered when the seismic weight of any flow is more than 150% of that of the floor below. Right? So for example, I will show you a figure in the next slide. You can see there as well. And if it is in the seismic zone 2, 3 and 4, dynamic analysis should be carried out. Okay, now let us go to the next slide. You can see over here we have mass. Heavy mass is there, and this mass is greater than 1.5 times of the story below. This you take, this is 1.5 times of the story below. For example, this weight is 100, then this weight will be 170. Okay, seismic weight is 100, this seismic weight is 170, then it is called to be looking at mass irregularity. So how can we achieve this mass irregularity? There are various methods, like we can increase the live load over here, or we can have walls as well. If we provide wall load, then also we will have a heavy mass on that story. For example, this story we are saying that we are having glassing is there, facade is of glass, whereas here we are having brick wall. At that time also we can have mass irregularity, or else we can provide live load, greater live load, or dead load, or any other load. You can provide the live load because we are saying that we can have a gym equipment will be there, or we can use it for any other purpose as well. So now we will model it in ETABS, the new model in ETABS, using the built-in settings, metric, Indian codes, 800 and 456 for concrete design. Okay. Now we have to select the grid lines. So grid lines in X, there are 4 grid lines, and each grid line we will take as 4 meters. We'll take number of stories as 3 and we'll continue. Okay. Okay. Yeah, this is our grid line. Now first what we have to do is we have to define materials. So add new material, Indian, and concrete. We'll take M30 concrete. Okay. Next, another add new material. We'll take rebar. We'll take rebar of Fe550. Okay. Yeah. So here we have defined the materials, and we have defined properties as well. Next, defining section properties, frame sections. Frame sections add new property. We'll take a rectangle. So we will take here square columns and rectangle beams. So column size, we will take column size as 300 by 380. We'll take rectangle column size 300 by 380. Okay. So M30 rectangular depth, 300 width 380. Right. Next, we have to define reinforcement. So we will take HYSD 550. This is column design, and we need not change anything because we are doing the analysis process first. Right. Now next, in the modifier, we have to define second. So important. What I will do, I will define new material property. So concrete rectangle. We will take here beams of same 300 by 380 sections, same singular sections. M30, depth of the beam will be 380 and the width is 300. Okay. So now modifiers. So this will be 3.35. Right? Okay. Now next we have to design reinforcement properties. So this is a beam section. So beam, this is beam HY50, 550, and if you want to change this one, you can change. Okay. If you would like to change, you can change it, the cover. If not, we can, no need to change, we can continue with this. So okay. Now what we have done is we have defined our section properties, and one more thing, we have to define our shell property, that is slab. The slab we are taking, right? So slab property need also to be defined. Okay. So we can edit this, modify or show. You can edit this one. And that is slab. Thin slab will take. We are taking it as a slab, not any other thing. So we'll take the thickness as 120 mm. Okay, here we'll provide it slab 120 mm. Okay. Right. Okay. Now we have defined all the materials. After defining all the materials, what we have to do is we have to place them. So while placing, what I will do is I will select this. We have to first place the columns. Columns need to be placed. So selecting the column. Column we have already designed 300 by 380. What I will do is I will place the column. Right? In the shortcut way, I have placed all the columns. So sorry, we see that here we have not seen. So here it is in the top story. What we have to do, we have to place in the bottom story first. So you go to bottom story. So this is the ground story, and we'll place it again over here. Right? Yes. Here we have placed everything. Now after this, we have to place the beams. Beams need to be placed. So for drawing quick beams, we'll select again beams and we'll place it. Again, all our beams are connected, all our beams are placed. Now what we have to do, we have to place the floors. Slab, we have to select slab 120 mm. Slabs are also placed. So these are the techniques with which you can do quick modeling. Okay, we have to go to ground floor and we have to make sure that these all are hinge support, but in actually they will be fixed support. So assign, join, restraints will take as a fixed connection. So as we can see, it will be fixed now. Now you can see it is a fixed connection. Right. Now we go again to this level. Now at this level we have defined. Now what we have to do, we have to assign loads. We'll define load pattern. We are having dead load and live load. Okay. I will add new load. Live load. This is mass irregularity. MI. Live for mass irregularity. I am adding. Add new load case. Okay. Fine. So what I will do, I will assign shell load. Uniform load. For that I have to select these shells first. Okay, I have selected all the shells. Dead load will be assigned automatically. So live load I am assigning. Live load is 2 kN. It is acting in the downward direction. Apply. And okay. As you can see, live load is assigned. Now what I have to do, I have to, for assigning mass irregularity, we need to have at least one floor where the load will be 150 times. Now here our modeling is completed, right? Again we have to select this number. I will go here. This, select the members, and we will replicate them. Edit, replicate, right? We have to replicate it on the stories. Right, we have replicated them to all the different stories. Now we have the movie. Now what I am going to do is, you can see over here, this number we are in 3D now. Here, again here we came back. So here you can see we are at second floor. We go to third floor. On third floor, as per ISO it says it should be more. Now I will assign here. Here I will assign shell load. Uniform shell load I will assign. So this is mass irregularity load. So this will be 1.5 only. 1.5. It should be 1.5 more, na? So the previous load was 2 kilonewton. So for 2, multiply it by 1.5. So how much should be? If you can do the calculation, you will get. So how to do it? Simple calculation. How to do it? 2 into 1.5. So the total load should be on that level. It should be 1.5 more. It should be 1.5 times more. So to be on safer side, we will take 4.5 kilometer. Previous is 2, okay, or you can take 4.75. Okay, apply. Now as you can see over here, in the bottom story, there is not there. Only on third floor, story 3. On story 3, we have assigned the load. On remaining stories, it is not there, right? Now, because we are doing earthquake analysis, we have to do load pattern. We will assign new load, that is EQX, and this will be seismic load. And how to do that? With IS 1893-2016 load. Okay, add new load case, and we will add it in the y direction as well. Add new load case. So we have to modify. While modifying, we will take it on the x-axis. Okay, eccentricity, top story, bottom story, response is there. So we are taking it in zone 5. Soil type 2 and important factor 1.2. This you should remember, because in the next we have to assign the same thing. Zone 5, importance factor 1.2. Here time period you can calculate it as per IS 1893, or you can use program calculator. Okay. Now our modeling is complete. We have assigned the loads, we have given the seismic load as well. Now what we have to do is we have to run the analysis. So while running, what we have to do? Let's stop. I will create a new folder. I will assign Mass Irregularity Modelling. Okay. So the model is to run now. So friends, now here analysis is completed. As you can see, we got the deflection shape as well. There are various methods where we can extract the results. So here you see we have display. Here display, you can see undeformed shape or stress strain diagrams, and we have story response plots as well. So this is story displacement. You can get the story displacement from over here. Directly you can get it. As you can see here, we are having at story 3, we provided heavy mass, right? Because of that there is drastic change. We will see that now. For which load this is? This is for dead load. Now we will see for earthquake X load. Now you see, this is the variation. Seismic weight is increasing over here. Again you can see with earthquake by resisting, right? Now we can go to this figure. You can have only a 3D figure and you can have the shear force and bending moments diagram. We have not provided any load case, so if you have load combinations, then that would be better. So rotate it to have a different angle. These are the different values we are getting. Okay, and the most important thing that we have to check now is tables. In tables, you can check all the required data that you need. So story output. In story output, you can see base reactions, modal participation factors, and story forces, story stiffness. What are all those? Okay. Since here we have not defined mass source, you will not get center of mass, all those details. If you define mass source, you will get all those details. Okay. So here you can get the results. So what I will do is, I will remove, will provide the results only for this one, and EQX, EQ1. Okay, EQX, EQ1. So here you can see, even you can reduce it, you can only go to EQX. Stop big enough. Right, here you can see what is the force. For life, here there is no actual force. Here we are getting the from here we are getting the actual force. So the story forces. Now the most important is the shear. Here you can see the variation we are getting. This was 141 and here it increased more than, it is around double, right? 140, its double is 280, so it is less than somewhat of this. So from again here, the change is very less because the self-weight on that story is very less. So this is the comparison and you can see that here the load is increasing. Here we are having higher shear. Because we are having mass distribution is not proper, mass irregularity is there. Okay, so now I will just show you one more thing. So here what I have said was, what the clause says, it should be more than 150% of the floor below, right? Right, it says this one. So what is the live load we have taken? Live load we have taken is 2 kilonewton per meter square, right? We have taken that live load. And live load, that is for mass irregularity, what we have taken? For mass irregularity, what we have taken it to be 4.75. 4.75 kilonewton per meter square. This is what is there. Now you can see at story 3, load at story 3, load at story 1, what we have taken, load at story 1 is only live load, that is equals to 2 kilonewton per meter square, and load at story 3, what we have taken, live load plus live load mass irregularity. Right. So how much we got? 2 plus 4.75, that is equals to 6.75 kilonewton per meter square. Now you can see here 6.75, what is the value of it? So comparison. So what is the value? 6.75 divided by 2. What is the answer you will get? You will get it as 3.325, I guess. It will be 3.325. sorry, 3.375. So this value is greater than 1.5 times. Okay? 1.5 times. So what we can say? We can say that the structure is having mass irregularity. Okay. So thank you friends. So this was about mass irregularity. I will be making such videos. You can click on the like button and subscribe to my channel to stay updated.